Hey, how you doing? क्या चल रहा है? How's this awesome Tuesday evening treating all of you? You should be able to see me right about now. What's up? Last part of chemical bonding. बड़ा सा लंबा सा chapter. I know. Generally लोग उसको it's a little blurry. Hold on, let me fix it. Hold on. Blurry, blurry, blurry. Okay, should be better now. Should be better now. Yay! Last part of chemical bonding. Yeah. So, have you been reading the NCERT? Have you been solving the subjective questions? I know जो order हम लोगों ने follow किया था वो slightly different from what was in NCERT. तो ये last वाला session is going to be a little chill. It's going to be those बीच वाले parts जो थे ना hydrogen bonding and all that. That's what we're going to cover. नहीं hydrogen bonding तो end में था और छोटी-छोटी चीजें हैं. Primary will just cover that up. Good evening Tirtha, how you doing? ठीक है. चलो let's get started right away. Homework questions तो मैंने गलती से class में solve कर दिए थे. तो we'll just start with some theory. Yeah. So intermolecular forces, we're going to get into the depth of hydrogen bonding. क्या होता है intramolecular, etc. Basic idea हम लोग cover करेंगे इसमें. And again, this is going to be a short session. From Thursday, we will start a revision of all of physical and organic chemistry. ठीक है? Same times as usual. Okay, चलो, let's start right away. Intermolecular forces, attractive, repulsive हो सकते हैं. Our focus is going to be on the attractive forces, okay, right now, because attractive forces mean bonds being formed, bonds, they lead to boiling point, melting point, those kind of physical properties that you see that are very different. Like pani ka, for example, pani ki boiling point is so much higher than that of say SO2, right? H2O and SO2. एक minute. H2S, sorry. Like एक minute, H2S doesn't make sense. इन दोनों में, right? What difference? This is a gas, this is a liquid at room temperature. So that's mainly because of hydrogen bonding. We'll look at that. So we'll look at what are weak chemical forces and like van der Waals forces in some detail. Okay? There are three of them basically. Dipole-dipole interaction, which are the strongest ones, followed by dipole-induced dipole, and then dispersion forces, which are basically dipole-induced dipole forces itself. Okay? You don't have to worry about these names. There's something called a Keeson force here, a Debye force, and a London force. But you need to know that which of these is strongest and which of these are weakest. Dipole matlab, there was a dipole that existed before anything ever came. Like HCl is a molecule that always has a dipole. Whereas something like I2, matlab, which is just this bonded, there is no dipole that exists. But because of its size, there could be something जो उसके आसपास है that could induce a dipole. Induce मतलब कि कुछ charge separation होने के chances हैं, somewhere of that sort. This is what this is talking about. Dispersion forces would be here and dipole forces would be here. If you have any doubts as always, please let me know. This is going to be a little bit of a theoretical question, theoretical idea, okay? But by now, you have an idea कि भाई dipole forces होते क्या हैं, right? Hold on, just quickly checking because in the last time that I started, I did not start the session in the JEE वाला thing. I have started the session, just quickly checking. ठीक है? So you do know what exactly dipoles are, right? Dipole moment क्या होता है हम लोग डिटेल में कर चुके हैं and how to calculate it from the structure of Vesper theory, VBT and all that. You can say, for example, like SO2 is a polar molecule, right? And whereas CO2 is non-polar, right? So these ideas also will come into the picture over here. So dipole forces will exist between polar molecules. That's the first step. And these are electrostatic attractions between oppositely charged ends of permanent dipoles. Matlab, what is a permanent dipole? This guy here. Yeah, we had this, right? A vector sum of all the dipoles of the individual bonds that gives you a permanent dipole in the molecule, right? Or unke beech mein electrostatic interaction, that's what we're talking about. And because of this, gases are easy to liquefy. So if something has high dipole forces, gases are easy to liquefy. The exact same thing that I gave you, H2O versus H2S, right? At room temperature, this is a liquid, this is, well, not, right? This is not, but this has to do with hydrogen bonding, a different idea. So we'll talk about this one later. So if you want to compare, say, CO2 and say SO2, so it is possible for us to say, look, one of them will be easier to liquefy than the others. Which one? The one that has better dipole forces. That's the general idea. Okay. So this idea is definitely extra. So I don't think we should talk about it too much. Yeah, let's just ditch this. This is definitely not an insert. Let's just forget about this slide. You never saw this. Like flash, it's gone. So if you see two HCl molecules, let's look at that. यहाँ पे बहुत ही clearly there are permanent dipoles that exist. Which means that if you want to draw the diagram, right? It starts from this way and goes, it starts from here and goes towards a negative guy, right? Is this correct? Is this correct? Is this the correct way of writing this dipole or a thing? Please let me know in the comments. Teethraj, anybody else who's here as well? Is this the correct way of writing the dipole wali cheez? Yeah? Do you remember from the earlier sessions? हमने कैसे किया था? When we did this whole NH3 versus NF3, right? यहाँ पे electrons थे. We said कि this is the direction of dipole moment, right? अमोनिया का क्यों dipole होता है ज़्यादा NF3 से? NF4, sorry, not 3. Let's say this. No, it was NF3, not NF4. What am I saying? NF3 से, because इधर dipole moment का direction उल्टा है. Okay, and these cancel out, and इसका dipole is much more than इसका dipole, right? So it starts from a positive and goes to a negative end. Okay. Anyway, so between this negative delta partial negative and between this partial positive, there is some sort of a weak interactive force between this. Now, this is between two molecules. Okay, this is important. I'm not talking about inside the same molecule itself. Hey, good evening, Lavanya. Hey, Radhika, how are you doing? How are you doing? I know आज का session थोड़ा देर से शुरू हुआ. We're supposed to start at 7. I changed the timing to 8:30 today. Yeah, just for today. Don't worry. We'll start at 6 or 7 on the other days. Okay. So dipole forces between two different molecules कि हम लोग अभी बात कर रहे हैं. For now, ठीक है. What is dipole? Induced dipole. Now, say one molecule that has a permanent dipole goes close to something that does not have a permanent dipole. It induces a dipole there. That is what we are talking about. हिंदी में बोलो क्या? NF4 at least. हाँ बिल्कुल तीसरा जो NF4 मैंने गलती से ड्रॉ कर दिया. NF3 ड्रॉ करना था. NF4 मैंने गलती से कर दिया. So a permanent dipole deforms the electron cloud of the non-polar molecule. That's all we are saying. So polarity is induced on the non-polar molecule. Hence it's called induced dipole. So for example, permanent dipole like HCl, non-polar species like say helium. I know helium तो बहुत ज़्यादा abstract हो गया. But say some sort of a non-polar species, and this will induce a dipole here. ठीक है? This is called induced dipole. All right. I'm great, Lavanya. How are you? Lavansh Donji. Yeah, I was just trying to remember the names. Here, this depends on the size. Okay, how polarizable the non-polar molecule is. What is polarizability? Vajan's rules and all of that. So, if the size is large, okay, then it is polarizable, right? Large anion. Do you remember that? वही same idea. A small cation polarizes a large anion. अगर ज़्यादा है तो charge separation ज़्यादा possible है. Okay. The dipole moment is present in the permanent dipole, but this induces this guy. So polarizability of the non-polar molecule, अगर ज़्यादा है तो induced dipole ज़्यादा होगा. And in this case, interaction energy is also same as the last one. वो मैंने discuss नहीं किया था. Proportional 1 by r power 6. R is the distance between two molecules. Don't worry about this. I've given you a general idea. एक सवाल लेते हैं. Let's take a quick question. Dipole-induced dipole interactions are present in which of the following pairs? Dipole-induced dipole. मतलब one of these molecules has a permanent dipole, the other one does not. The one that has a permanent dipole is inducing a dipole moment in the one that does not have a permanent dipole. ज़्यादा बार same चीज बोली. Try करो ना सवाल. Answer दो. Give me the answer in the comments. हाँ, उल्टा जाते हैं. Cl2 ये तो दोनों non-polar है. Both of these are non-polar. Doesn't make sense. Here both are polar. सही है. Here also both are non-polar. Here ये है polar, ये है non-polar. So इसीलिए आंसर मेरे हिसाब से होना चाहिए. You are Lavanya. That's good. आंसर तो बताइए इसका. आंसर इसका बहुत सिंपली होना चाहिए A. Right? This is from NEET 2013. इतना straightforward question. Okay. Did you understand what happened here? ठीक है. ये दोनों polar हैं तो इनके बीच में they won't be dipole induced dipole. It will be dipole interactions. Okay. एक डाइपोल दूसरे डाइपोल को इन्फ्लुएंस करेगा. इनफैक्ट देयर इज अ स्पेशल थिंग दैट हैपेंस ओवर हियर. पानी और अल्कोहल के बीच में इट फॉर्म्स एन अजियोट्रोप. सॉल्यूशंस चैप्टर में आप पढ़ चुके हैं इस चीज को. ए, यस, तीर्थराज, राधिका, लावण्या, एब्सोल्युटली राइट. ए इज द राइट आंसर. गुड जॉब. ठीक है. आई थिंक देयर इज अ बिट ऑफ अ लैग बिटवीन व्हाट आई एम सेइंग एंड व्हाट यू गाइस आर गेटिंग. लैग थोड़ा 20 सेकंड 10-20 सेकंड का. खैर, द थर्ड टाइप व्हिच आर डिस्पर्जन फोर्सेस. मतलब कि डाइपोल था भी नहीं, अभी है भी नहीं, बट समथिंग इंटरेस्टिंग हैपेंस. Okay, they exist in atoms and non-polar molecules like H2, O2, Cl2 in solid or in liquid states. दोनों में करता है. And they are electrically symmetrical. मतलब they have no permanent dipole. इसमें भी होता है. कैसे होता है? There is a small imbalance for a very small time. थोड़ा सा imbalance होता है चार्ज में, इलेक्ट्रॉनिक चार्ज डिस्ट्रीब्यूशन में. That leads to polarization उसके बगल वाली स्पीशीज में. So this is called instantaneous dipole induced dipole interactions. अंग्रेजी ज्यादा होगी. Instantaneous मतलब बहुत शॉर्ट टाइम के लिए, बहुत जल्दी होता है. डाइपोल इंड्यूस्ड डाइपोल इंट्रैक्शंस. डाइपोल था नहीं, but suddenly कोई नेगेटिव चार्ज इसका यहां वहां चला जाता है, इसकी वजह से it messes the distorts the thing a little bit. And this is also good, but this works at a very very short distance. So see, the best example for this is something like an I2 molecule. Okay, दो I हैं and उसके बीच में there is like a small distortion happening, and because this यहाँ प्लस है तो यहाँ पे माइनस हो गया, ठीक है, and it goes away, and it's valid only for very very short distances. And again, the magnitude of London forces is proportional to polarizability. मतलब कि iodine is going to be a lot more than bromine, it's going to be a lot more than Cl2 and F2 etc etc. ठीक है, here you go. मैंने आंसर ऑलरेडी दे दिया, because HCl and He are non-polar. Absolutely, absolutely. Good evening. Hey Sami. Yes, Lavanya, absolutely right. How about this question? Which of the following molecules is the dispersion force likely to be the most important factor in determining melting point and boiling point? इसका मैंने हिंट आपको दिया था, बार बार बोला था, पानी और H2S को कंपेयर करो. अगर फोर्सेस ज्यादा है, व्हाट इज बॉइलिंग एंड मेल्टिंग एनीवे? आंसर सोचो आप. आई गिव यू सम थियरी और कॉन्टेक्स्ट. बॉइलिंग मतलब कि जो दो मॉलिक्यूल के बीच में इंटरेक्शंस हैं, दैट आई एम ब्रेकिंग अपार्ट. आई एम नॉट मेसिंग विद द मॉलिक्यूल इटसेल्फ. मैं उस मॉलिक्यूल की फोर्सेस को नहीं तोड़ रहा हूं, बट दो मॉलिक्यूल के बीच में जो फोर्सेस है, आई एम स्प्रेडिंग दैट आउट. व्हाई? जस्ट बिकॉज ऑफ हीट. By giving heat, they start vibrating, start moving around, and they break free of those interactions. What are these interactions? यही dipole dipole हो गया, या फिर dipole induced dipole हो गया, या introduced या तो induced dipole हो गया. Either of these three things. But in this case, since दो substances नहीं है, एक ही substance है, there's only one substance, right? So, it's only one substance. अब कैसे करेंगे उसको? सोचना पड़ेगा, है ना? In this, the size factor or the polarizability factor takes precedence. ठीक है, because you may be like, देखो ये तो polar है, right? Both of these are polar. So this versus something like this, how do you decide? Okay, both of these have, what do you call them, permanent dipoles, right? But इसका साइज इतना ज्यादा है ब्रोमीन का, इसका पोलराइजिबिलिटी इतनी ज्यादा है कि although it has instantaneous dipole, इसका जो है सबसे ज्यादा होगा. और बाय द वे, इफ यू वांट टू चीट, यू कैन चीट इन डूइंग दिस. हे समी, आई एम गुड, हाउ यू डूइंग? द चीटिंग पॉइंट इज, यू नो दैट ब्रोमीन इज अ लिक्विड एट रूम टेम्परेचर. यू नो दिस, राइट? अगर इंट्यूशन नहीं भी बिल्ड कर सकते हो तो ठीक है, डजंट मैटर, राइट? ब्रोमीन लिक्विड एट रूम टेम्परेचर. ऑल ऑफ दीज आर गैसेज यार. दिस इज द हैकी वे ऑफ डूइंग दिस, व्हिच इज आल्सो वर्क, राइट? एमसीक्यू में किसी ना किसी आंसर निकालना है. दिस इज द बेस्ट वे टू थिंक. अगर रूम टेम्परेचर पे ये लिक्विड है तो ऑब्वियसली इट हैज स्ट्रॉन्गर फोर्सेस एज कंपेयर्ड टू द वंस दैट हैव गैसेस, राइट? हे असनैन, हाउ यू डूइंग? या तीसराज, या इट इज डेफिनेटली ऑप्शन है. डू यू गाइस एग्री विद दिस लॉजिक? सोच के बताइए, इज दिस लॉजिक ओके जो मैंने सर के ऊपर लिखा है मेरे? लावण्य, आई एग्री, राइट? बट डिस्पर्शन फोर्सेस इतनी ज्यादा है उसमें, इतनी ज्यादा डिस्पर्शन फोर्सेस हैं कि इट बिकम्स अ लिक्विड. इट बिकम्स अ लिक्विड, है ना? और ये भी, इनफैक्ट इवन दिस इज पोलर. यस, थैंक यू लावण्य. हे कृष्णा आदित्य, वेलकम. इज दैट उनका नाम क्या था? अरे हाउ कैन टेस्ला? इज दैट टेस्ला? कृष्णा आदित्य योर पिक? खैर, the order of strength again is dipole dipole सबसे ज्यादा, then dipole induced dipole, and lastly dispersion. But take that with a bit of थोड़ा सा grain of salt. We just saw an example जहां पे bromine was a liquid, whereas all these other things they were gases. And bromine में dispersion forces, although they are weak, it's a liquid at room temperature. ठीक है, all right. So polar molecules can also interact by London forces. ठीक है, चलता है. This is obvious, right? Let's move on. Last idea already. 10 मिनट हुआ है, 15 मिनट हुआ है. नहीं, not the last idea. We have picture थोड़ी सी अभी बाकी है दोस्त. 10 more minute, 15 more minute maybe. Attractive forces known as hydrogen bonding are very interesting. Hydrogen is the, कि electronegativity कम है as compared to other molecules, especially when you're talking about covalent compounds. Okay, जैसे हम लोग गैसेस की बात कर रहे हैं ज्यादातर आजकल, ठीक है, गैसेस लिक्विड्स की बात कर रहे हैं, सॉलिड्स की तो कम बात कर रहे हैं इस केस में. They bind the hydrogen atom molecule because of the electronegativity difference between F, O and N. तो मतलब अगर the atom that you're talking about, okay, the compound that you're talking about has F, O or N there, then it can form some sort of a weak interaction with hydrogen because of electronegativity difference. In fact, nitrogenous bases कहाँ होते हैं? नीट के दोस्तों DNA में, right? This is what forms the secondary. Help me with this one. Secondary structure. What is the right term for this? The backbone of DNA, right? Sure, you've got those AC, GT, and all that, but the two strands are connected because of the hydrogen bonds. And what is that called? Is that called the secondary structure, or उसको कुछ बोलते हैं? It's got some formal term around it, right? Can you help me with that? It is Nikola Tesla. Yeah, absolutely, great. So yeah, hydrogen bonding literally holds DNA together. You already know all of this, right? But I'm just trying to tell you this is pretty important, right? So these dot are basically just trying to show hydrogen bonding. These are not real bonds. What is the real bond anyway? Now think about it. Real bond hai kya? Well, a real bond, according to chemistry, is कि it change if you break it or if you form it, you get a completely different substance. Now in this case, hydrogen bonding affects the physical properties. It it doesn't break apart this itself. I was choosing my words carefully because hydrogen bonding does lead to some chemical properties as well, some interesting chemical properties. कुछ reaction होते ही नहीं है because hydrogen bonding इतनी strong है, या फिर बहुत जल्दी जाते हैं because hydrogen bonding है. खैर, yeah, this is like a gray area, right, with hydrogen bonding. So it is covalently bonded to some X, and the shared pair of electrons moves far away from hydrogen. So इसमें that's why it gets a delta plus and delta negative charge. Okay, partially positive or partially negative. So almost like ionic. You remember when we did Fajan's rules, we said there's partial ionic, partial this thing, covalent character. Yes, बोलिए लावण्या. When are you going? Yogi is asking, chemistry in JEE. सही है बेटा. JEE कब शुरू करेंगे? So Yogi जी, Yogi नहीं, Yagya जी. Tesla जी, I'll call you Tesla. Let's call you Krishna. I like the name Krishna. So Krishna जी, हम लोग शुरू करेंगे revision sessions on both JEE and NEET channels in parallel. ठीक है? और दोनों हम लोग थर्सडे को शुरू कर रहे हैं. एंड व्हाट वील डू इज एक 11th का चैप्टर, एक 12th का चैप्टर, दोनों साइड बाय साइड करेंगे. ठीक है? सो जल्दी आएगा विद इन द नेक्स्ट कपल ऑफ वीक्स. ऑल्सो what I'm teaching here, the theory is very, very useful for JEE Main as well. Check out the things I've done on whatchamacallit. इसी में links हैं, right? Look at Vesper theory and VBT. You will definitely get JEE Main के सवाल, JEE Advanced के सवाल इससे हो जाएंगे. What I've taught on NEET. Not because I've taught a lot, because I've taught from basics. मैंने JD लेके पढ़ा है. ठीक है? All right. Anyway, so hydrogen is bonded to electronegative element, and at least एक lone pair होना चाहिए electronegative element में. एक lone pair. हाँ. Okay. So basically, ammonia, if it is this guy here, right? If it forms this, then इसमें hydrogen bonding is not going to happen. Okay. But in this, there is hydrogen bonding, okay, because there is at least a lone pair. That is what we are trying to say, because those lone pair of electrons itself, those are the ones that take part in hydrogen bonding. ठीक है? Okay, sweet, super duper. Second point. Which second point? If you don't understand something, just tell me, can you explain this specifically? If you say second point, it's hard for me to say कौन सा second point. Which second point? I'm just trying to see where did I point out point number 1, point number 2. Anyway, super duper. Can you tell me what is the second point? And then sure, I will explain it. Oh, yeah? You're talking about this second point? Shared pair of electrons move away from H atom? Hey, another Krishna. Hey, Krishna Jaiswal. You remember? That's great, Lavanya. That's great. For class 11. Yeah, I just told you, Krishna Aditya. I told you. Second point, kaun sa? Jaldi se bataiye, super. This shared pair of electrons move far away from H atom? Yeah, because H is less electronegative than X, right? So X will pull electrons away, as simple as that. Yeah. Lavanya, this is going to end 1 घंटे से पहले ही खत्म हो जाएगा because it's a slightly short session. So I'm guessing 15 minutes, maximum 15 more minutes or so, 15-20 minutes, 40 minutes का total session होगा. I think so. We'll see. ठीक है? जल्दी हो जाएगा. Little bit of theory covered थी, तो मैं सोचा कि एक ही सेशन में खत्म कर देते हैं. थोड़ा बहुत शरीर बताए. कृष्णा, कृष्णा, yes, करेंगे. Let's talk about bonding here. If you want to chat with me about something that's not this what you're talking about right now, ping me on iTeachCam on Telegram or Discord. Yeah, that will be good. ठीक है? Okay. All right. Super duper. समझ में आया? Simple stuff. Yeah. Electrons basically get pulled towards this. Yeah. यही तो हम लोग draw कर रहे थे. You remember those dipoles and all that. All right. Sweet. So the strength of the hydrogen bond is going to be proportional to electronegativity of the element X. मतलब कि ऑक्सीजन के साथ हो सबसे ज्यादा, फिर नाइट्रोजन नहीं, नाइट्रोजन सबसे ज्यादा, देन ऑक्सीजन, देन अदर गाइस, राइट? नहीं, फ्लोरीन से सबसे ज्यादा होगा, देन ऑल ऑफ दीस अदर गाइस. एनीवे, और अगर बड़ा एटम है देन हाइड्रोजन बॉन्डिंग कम हो जाती है. इनवर्सली प्रोपोर्शनल मतलब बड़ा एटम मतलब हाइड्रोजन बॉन्डिंग कम हो गई. ऑलराइट, स्वीट, ग्रेट कृष्णा. We will do PYQs for sure. Okay. You're talking about something else. Sorry, I missed your point. You said NCX and INCHO on J channel. Krishna Aditya, if I do that, 90% audience will run away. मैंने एक बार जूम डाल के सवाल किए, सब लोग भाग गए थे, बट ठीक है. That's a great input. Krishna, if you have specific requests, जैसे on a radio channel, you say कि ख्वाहिश है इसकी, you tell me the question you want me to solve and I'll solve them specifically. If I generally solve question ना, लोग भाग जाएंगे. I did try doing JEE advanced content on the JEE main channel and JEE channel and yeah, बहुत कम जनता आ रही थी देखने के लिए. So I was told, भाई stick to JEE main content. But sure, as soon as JEE main gets over, by the way, slide this थोड़ा सा हम लोग अलग पढ़ रहे हैं. JEE main का पहला अटेम्प्ट खत्म होता है, उसके बाद हम लोग JEE advanced, पूरा ही JEE advanced ही करने वाला हूँ मैं. सिर्फ JEE advanced के सब्जेक्ट में सवाल करने वाला हूँ. I'll do that then. Krishna, thank you for the input. आस्क करिए सर, PYQs करने थे सो इसलिए से आस्क करिए. PYQs करने थे, अच्छा लावण्या. शेख, व्हाट्सअप. वो करेंगे, PYQs करेंगे. PYQs कितने करेंगे? केमिकल का बॉन्डिंग का तो पूरा ही कर चुके हैं, इसके क्या ही PYQs बचे हाइड्रोजन बॉन्डिंग के. बट या इन द रिवीजन पार्ट्स वी विल डू ऑल ऑफ दैट. या श्योर कृष्णा, श्योर. थैंक्स फॉर द इनपुट. सो द स्ट्रेंथ ऑफ द H bond is figured out by Coulombic interaction. Coulombic मतलब electrostatic. Okay, which is very interesting. Electrostatic interaction between lone pair of the electronegative atom and hydrogen atom. थोड़ी सी थ्योरी जो जरूरी है. एंड ऑब्वियसली हाइड्रोजन बॉन्डिंग सबसे ज्यादा होगी सॉलिड स्टेट में एंड सबसे कम होगी गैसियस स्टेट में. हियर द क्विक क्वेश्चन. द बॉइलिंग पॉइंट ऑफ नोबल गैसेस आर इलस्ट्रेटिव ऑफ ऑपरेशन ऑफ द ऑपरेशन ऑफ फोर्स ऑफ द टाइप व्हिच वंस? नोबल गैसेस का बॉइलिंग पॉइंट कम ज्यादा है, जो भी है, क्यों है? इज इट बिकॉज ऑफ डाइपोल इंड्यूस्ड डाइपोल, आयोनिक or London dispersion forces? What do you think? Okay. Yeah, that's the last topic. That's awesome, Krishna. That's good, dude. That's great. Ping me on iTeachCam, man. I can help you out with material. Yeah. It's awesome that you're doing this on Telegram or Discord, and I can give you specific things to do for JEE Advanced for sure. Yeah. Other modules question mere pending the, Lavanya. Okay, which one are you talking about? Can you solve this question, guys, please? मॉड्यूल्स की जरूरत नहीं है, प्लीज करिए पहले एनसीईआरटी. मॉड्यूल्स आर ग्रेट बट पहले एनसीईआरटी करिए. एनसीईआरटी के सब्जेक्टिव सवाल सबसे पहले करिए, फिर मॉड्यूल्स वी विल डू. मॉड्यूल्स आर ग्रेट बट पहले आप एनसीईआरटी का इनसाइड आउट खत्म करिए एंड देन एवरीथिंग एल्स इज नाइस. प्रैक्टिस के लिए तो आई नो कि इट इज एन एमसीक्यू पेपर, तो आपको एमसीक्यू की प्रैक्टिस चाहिए, तो मॉड्यूल्स आर गुड बट उससे पहले एनसीईआरटी. आई ऑलवेज से दैट, आई विल ऑलवेज कीप सेइंग दैट, रिमाइंडिंग यू ऑल टू रीड एनसीईआरटी. I'm even making shorts on that idea. मेरे दोस्त लोग में बोलते हैं, दोस्त लोग मतलब colleagues obviously are saying, यार you guys should make shorts. Shorts, you students seem to like shorts. So I'm making shorts telling you guys to read NCERT and seems to be doing all right. Yeah. All right, Krishna, see you. Absolutely right. D is the right answer. Simple वाला है Lavanya. Yeah, simple answer. D is the right answer. NCERT is done. Excellent, Lavanya. Then you do. आकाश के मॉड्यूल्स करिए, बहुत डिटेल है, बहुत प्यारे मॉड्यूल्स हैं. आई वाज जस्ट लुकिंग थ्रू द आकाश मॉड्यूल यस्टरडे. आई एम नॉट जस्ट मेकिंग अप. ऑफिस में पढ़ा था एंड आई वाज लाइक, ओह दिस इज ग्रेट, आई वांट टू सी ऑल ऑफ देम, आई वांट टू गेट एक्सेस टू ऑल ऑफ देम. सो आई एम ट्राइंग टू डू दैट एंड गेट यू क्वेश्चंस फ्रॉम देयर. या, आकाश इज ब्रिलियंट फॉर नीट एंड फॉर जेईई. लावण्या, एनसीईआरटी डन. तीसरा सेइंग डी, लावण्या सेइंग डी, राधिका सेइंग ऑप्शन डी. या, सिंपल फन. लेट्स मूव ऑन. सो द वैल्यू ऑफ and the H bond is very interesting. It goes between 10 to 1000 kilojoule per mole. और रेगुलर केमिकल बॉन्ड कितना होता है? What is the regular chemical bond? So 50 to 80 kilojoule per mole? No, this was regular. This is, I think, is between 300 to 400 kilojoule per mole, right? Yes. हमने किया था. How do I remember 300 to 400 kilojoule per mole? You remember वो जो हमने हेस लॉ वाले आइडियाज क्वेश्चंस किए थे थर्मोडायनेमिक्स में, वहां से मुझे ये नंबर याद आ रहा है. मे बी अ बिट ऑफ, बट आई थिंक कि CH बॉन्ड का समथिंग वाज अराउंड दिस मच, राइट? हसनैन जी, श्योर, follow the Telegram channels and we'll give you this. I teach on right now Tuesdays, Thursdays and Saturdays. कभी कभी सैटरडे के बजाय संडे हो जाता है, but most days that's the thing. And the timings are 6 o'clock या 7 o'clock for NEET, and JEE पे I teach at 11:30. This is on weekdays, and weekend में swap कर रहा हूँ मैं. Weekend में 1 PM is on NEET. Anyway, follow the Telegram channel, guys. You will get all the latest updates there. All right, Hasnain. ऑफलाइन क्लासेस ज्वाइन करी है तो मॉड्यूल्स से बहुत अच्छे अच्छे कॉन्सेप्चुअल क्वेश्चन दिए हुए, मजा आ जाता सॉल्व करने. बिल्कुल सही बोला लावण्या. मॉड्यूल्स में बहुत सही है. यू हैव टू हैव गुड क्वेश्चन प्रैक्टिस. आई अंडरस्टैंड सम ऑफ यू डोंट हैव एक्सेस टू दीज अमेजिंग मॉड्यूल्स दैट लावण्या इज टॉकिंग अबाउट. Go to the Aakash BYJU'S app, boss. The app, I'm just calling AB because that's the internal thing. We just call it AB, right? AB is Aakash BYJU'S. The app is fascinating. I'm not just doing random promotion of the app. It is actually good. मैंने खुद बैठ के उसमें सवाल बनाए हैं, उसके solutions बनाए हैं back in 2016, and from then to now, hundreds of amazing people have come here in the chemistry team, physics, maths, and subjects who have made crazy questions and crazy solutions. Literally nobody has made better solutions in India. I am saying that confidently. और जो भी बनाए हैं तो यहीं के लोग बना के जाके गए बनाए हैं सवाल के सॉल्यूशंस. सो द बेस्ट सॉल्यूशंस यू विल फाइंड ऑन दिस इटसेल्फ. ओके, खैर, सिंस लावण्या ब्रॉट अप, थैंक यू. ऑसम तीर्थराज, बहुत बढ़िया है, बहुत बढ़िया है. व्हाट आर द डिफरेंट टाइप्स ऑफ एच बॉन्डिंग? इंटर एंड इंट्रा मॉलिक्यूलर. इंटर मतलब दो अलग अलग मॉलिक्यूल के बीच में. इंटर स्कूल कंपटीशन, इंट्रा स्कूल मतलब कि ब्लू हाउस वर्सेस ग्रीन हाउस. इंटर स्कूल मतलब स्कूल, आपका स्कूल, CMR स्कूल वर्सेस एक या स्कूल और समथिंग. देयर आर डिफरेंट स्कूल्स. आई वेंट टू CMR, इसलिए मुझे याद है. NJS, नेशनल जूनियर स्कूल. खैर, एनीवे, so inter is between two different entities. Intra is within the same entity, within the molecule itself. ठीक है? Okay. Intermolecule का example, all we have seen so far are inter only. Okay, solid और liquid state में होते हैं, ज्यादातर दिखते हैं. And here is an example, right? HF के बीच में क्या है? Here they are थोड़ा far away and they come a little closer. That's inter. पानी में is the best example of this. Okay. Hold on, I missed some comments. Modules के BYQs question are best for NEET and solution module में डिटेल में नहीं देते. हाँ, I understand लावण्या. इसलिए बोल रहा हूँ check the BYJU'S app. Yeah, exactly. On the if you have access to the app, that's great. Or even the BYJU'S site, in fact, byju's.com or topper answer. Topper answer बोलते हैं अभी उसको. और just check out these sites. Yeah, so just when you have a question, type that question along with byju's.com. Anyway, पहला result BYJU'S का ही आता है या फिर topper का आता है. You'll have that, and a lot of those questions they have the option of giving things a thumbs up. So all the questions that have thumbs up में 4, 5, 10, 12, 20 सब thumbs up, and that means those are very very good answers. So there as well. अगर किसी चीज का solution चाहिए, you find it here as well. ठीक है, चलो. हाइड्रोजन बॉन्डिंग पानी में देख लिया, सिंपल चीजें ही हैं. इंट्रामोलिकुलर कब होगा? जब सेम मॉलिक्यूल में यू हैव टू डिफरेंट थिंग्स. ओके, एंड 3 केसेस हैं. अभी हम स्पेसिफिकली बेंजीन की बात कर रहे हैं. ऑर्थो, मेटा और पैरा. पैरा मतलब फार अपार्ट, एंड दिस प्रीटी क्लोज. सो इन दिस इंट्रा होगा, इन दिस इंटर होगा. There is a difference of electronegativity between G1 and G2. ठीक है, एग्जाम्पल इसका ये है. ऑर्थो नाइट्रोफिनॉल, दिस इज इंट्रा. ओके, एंड सैलिसाइल्डिहाइड आल्सो इज इंट्रा, क्योंकि बगल में ही there's a difference of electronegativity. Any doubt so far here? Are we all right? Solution module में नहीं रहते. हाँ, कभी कभी नहीं है तो वो see, because modules are limited by the physical space and जैसे कि न्यूज़पेपर में आप न्यूज़पेपर पढ़ते हो, न्यूज़पेपर में उतनी ही रियल एस्टेट जगह आपको उतनी दी, आपको जो भरना है वहीं पे भरना है, राइट? मॉड्यूल्स आर आल्सो लाइक दैट, बट इफ यू लुकिंग अप थिंग्स ऑनलाइन, दैट रिस्ट्रिक्शन इज नॉट देयर. ठीक है, तो इसलिए मैंने ऐप सजेस्ट की. ऐप पढ़ने में हाथ में फोन उठाना पड़ता है, बट इट्स इजी टू डू. ऐप और द वेबसाइट आई टोल्ड यू, मॉड्यूल्स आर ब्यूटीफुल. ओरिजिनल OG बोलते हैं ना, दैट्स मॉड्यूल. Here's an interesting fact. Okay, interesting fact about दिस होल आइडिया ऑफ प्लास्टिक स्टिक क्यों यूज करते हैं आइसक्रीम में? कुल्फी खाने किसी को मन कर रहा है? अभी तो ठंड हो गई है, कुल्फी तो नहीं खा लोगे आप लोग नॉर्थ से, बैंगलोर में भी कुल्फी खा सकते हैं। अ वुडन स्टिक इज यूज्ड फॉर एन आइसक्रीम बार एंड नॉट अ प्लास्टिक स्टिक। प्लास्टिक स्टिक यूज होती है क्या? नहीं, वो वुडन स्टिक का अलग से फ्लेवर भी आता है ना, इट्स वेरी नाइस एक्चुअली व्हेन यू ईट आइसक्रीम विद वुडन स्टिक। दिस आल्सो इज बिकॉज ऑफ हाइड्रोजन बॉन्डिंग, आई एम नॉट मेकिंग दिस अप। वुड में होता है सेल्यूलोज एंड सेल्यूलोज फॉर्म्स हाइड्रोजन बॉन्ड्स विद द वाटर इन योर आइसक्रीम। ठीक है, विद वाटर इन योर आइसक्रीम। आइसक्रीम क्या होता है यार? आइसक्रीम में पानी तो होता है, सो देयर इज मिल्क एंड ऑल, मिल्क फैट, पानी होता है, हर चीज में पानी होता है, ठीक है, एंड दैट्स व्हाट इट फॉर्म्स। एक सवाल देख लेते हैं। इन आइस, नॉट आइसक्रीम, इन आइस the length of hydrogen bonds is less than that of covalent bonds, is greater than that of covalent bonds, is same as that of covalent bonds, can be less, can be, ये हटा देते हैं। What is this can be less, can be greater? Let's move this. ठीक है, चलो छोड़ो, I'll leave that option also. Tell me. OH के बीच में हाइड्रोजन बॉन्ड है ना? Exactly. Hey, super is back. Okay. Is there any difference in stability? Super duper. Nitika ji is teaching GOC right now. Please attend those sessions. She'll explain in detail. But generally, stability wise, मतलब reactions में yes. Like for example, right? Some reactions will lead to वो जो क्या बोलते हैं ना, dehydration होगा उसमें. My organic is not so good. But this whole idea of, you know, if you have this sort of a thing, कितने बॉन्ड बना रहे हो आशीष? ठीक है, इसलिए मैं ऑर्गेनिक नहीं पढ़ा था। देखो, ठीक है, इफ यू हैव समथिंग लाइक दिस, देन दीज गो अवे एंड यू गेट एन एनहाइड्राइड, राइट, इन पर्टिकुलर कंडीशंस। सो स्टेबिलिटी, व्हेन यू से दिस, इज दिस व्हाट यू टॉकिंग अबाउट और आर यू टॉकिंग अबाउट समथिंग एल्स? सो केमिकल रिएक्शंस कुछ स्पेसिफिक केसेस में इफेक्ट होते हैं, बट यूजुअली इट्स द फिजिकल प्रॉपर्टीज लाइक मेल्टिंग एंड बॉइलिंग पॉइंट दैट वी आर टॉकिंग अबाउट राइट नाउ। ठीक है, अरे इसका आंसर तो बताओ दोस्तों, हम लोग टाइम पास से बात करें, इसका आंसर तो बताओ। The length of hydrogen bond is obviously going to be greater than that of covalent bonds. Why is it going to be greater? It's a weaker bond. Hydrogen bonds are weaker than covalent bonds. Okay? ठीक है? No doubts here, right? Doubt है तो पूछ लेना. I think this is pretty straightforward. Next question. What is the dominant intermolecular force or bond that must be overcome in converting liquid CH3OH into a gas? What do you think? Yeah. पिछला वाला B था. Yeah. What about this one? What about this one? हमने 4 चीजें पढ़ी अभी तक, 3 चीजें पढ़ी है। कोवलेंट बॉन्ड तो नहीं होगा, कोवलेंट बॉन्ड कहां तोड़ोगे? अगर कोवलेंट बॉन्ड तोड़ रहे हो तो भाई वो CH3OH बचेगा ही नहीं, तो यही 3 हो सकता है। Which one do you think it is? Because as covalent bond, their molecules and attraction makes atom closer and edge bonding and due to repulsion between center atom. सही है लावण्य? बहुत डिटेल में आपने लिखा। What about this one, guys? This is obviously hydrogen bonding, right? Yeah. Option A. Okay. Dipole interaction. अच्छा, I understand लावण्य ने dipole क्यों बोला। देखो, पानी में होता है डाइपोल एंड CH3OH में भी होता है डाइपोल। CH3OH कैसे ड्रॉ करें? थोड़ा मुश्किल होगा, बट ड्रॉ करके देख सकते हैं। Something like that, you're saying कि dipole होगा, but the thing is कि I'd like to go with hydrogen bonding over this dipole interaction because this is stronger. Dipole is general. Dipole interaction तो HCl में भी है, but HCl is a gas, right? But methanol, एक मिनट, hold on. अच्छा, liquid CH3OH into gas. या इधर भी तो हाइड्रोजन बॉन्ड नहीं होगा। मैं जो बोल रहा था वो पानी में डालने का, बट इवन इफ यू जस्ट टेक दिस, लाइक से 2 मॉलिक्यूल्स ऑफ दिस, ओके, तो दिस ऑक्सीजन विल प्रोबेबली इंटरैक्ट विद दिस, राइट? सो हेंस देयर इज हाइड्रोजन बॉन्डिंग हियर एज वेल, या हेंस इट शुड बी डी। राधिका, लावण्य, डू यू गाइस सी दैट? इट्स ओके, होता है तो इट्स ओके। स्ट्रेट फॉरवर्ड क्वेश्चन लगता है, बहुत ज्यादा आसान है, कभी कभी आगे पीछे हो जाता है। I agree with your idea of, कि dipole तो इसमें definitely है, but specifically because there is an electronegative element and hydrogen, so we will talk about specifically hydrogen bonding. In fact, HCl also will be called hydrogen bonding, right? It's all right. It's all right. Sami, what are you saying? Can I start studying from Aakash 2021 modules or do I need 2024 modules? Well, I think things have changed in the terms of the exam. थोड़ा बदल गया, right? 2021 और 24 के बारे में. The exact आकाश मॉड्यूल में क्या फर्क है at this point of time, मुझे exact idea नहीं है कि 2021 में क्या था. Yeah, 2021 मॉड्यूल में क्या था और उसमें how is it different from 2024 is not something that I know of the tip of this thing. The main difference would be कि you have 3 years more of content and stuff. So you see what is more beneficial for you, right? आपको जो भी सबसे यूजफुल लगता है, you take a call on that. ठीक है? There is no FOMO कि आपको यही लेना है, वो करना है. आप आराम से सोचो. You weigh the pros and cons और जो आपको ठीक लगा आप करो. But either way, we still have the most updated stuff. The tests are the best. I think if you get modules, the main thing you get is access to tests. And if you take tests, Aakash has a lot of people there, right? So like a lot of students. So you get to know where you stand, competition, all that. So that way, I think testing is great. Okay, well, let's get back to what we were talking about. Okay, nice, Deepa. Order to convert liquid gaseous state, strong hydrogen bonding must be broken. Okay, cool. All right. Next question. H2O boils at a higher temperature than H2S. Yeah, I started the session because of this. Bata do. All answers are going to be hydrogen bonding. Let's not spend too much time on this one. Right? This I already told you. This is going to be because of hydrogen bonding. Yeah? This is the main idea of, this is the best example of H2S and H2O. Super duper. For organic chemistry, Nitika is teaching amazing sessions. DNF log, मैंने किया है super duper. You can check it out. By the way, since you guys are asking right now, and this happens in a lot of my sessions, where some students are like, यार, and it's not a problem, super duper, पूछो जो पूछना है. आपको हक है पूछने का. पूछते हैं कि यार, where do I find this content? Where do I find that content? So I made a small this thing. I'll just share it with you here. कहाँ गया? मैंने एक बनाया तो था. एक मिनट. कहाँ गया ये? I made a small sheet. Okay, and this is again, if you find this very useful, you can share it. पूरी दुनिया से share करो जिससे भी है. So if you click on that sheet, you will see all the content that I have made. I can show it to you. Hold on. मैं कोई खोल के दिखाई देता हूँ यहाँ पे. So I think all the other teachers are also working on something like this. And वो लोग करेंगे आराम से. मेरे पास थोड़ा टाइम था तो मैंने ये कर दिया. 1 second. Let me share my screen since you brought it up. Just take a 1 minute or so का diversion from what we're talking about. And window capture number 5. कौन सी window कर रहे हैं? आकाश बायजूस YouTube Brave. यही है क्या? Brave.exe, Brave playlist. हाँ, यही वाला. Are you able to see my screen? नहीं, not right now. Are you able to see my screen now? अभी दिख रही होगी screen, right? How do I increase the zoom? बढ़ जाओ, zoom. You see that? Yeah. So I've made a whatever small Excel sheet which is in the comments, and this has all my sessions, right? Chemical bonding जो अभी ongoing चल रहा है, इसको I'll make it completed right now. ये तो हो गया है, but I can't change it. That's from a different account. खैर, if you click on this, you'll see whatever, right? DNF log कोई पूछ रहा था, यहाँ पे है, जो भी चाहिए मेरे यहाँ पे है. I've also suggested to the other teachers that they do this. Hopefully वो लोग भी जल्दी करेंगे. But I'll keep updating this, okay? वो link मैंने आपको जो भी chat में दिया है, that same link will get all the latest stuff. ठीक है? All right, let's get back to our session. Here you go. फिर से that link in case it got lost in the chat. Okay, आंसर देते हुए हाइड्रोजन बॉन्ड का लावण्या. Let's move on to the next question. No more questions. What we're going to do some theory. What did you say? Sorry, Lavanya, missed that. High electronegative atom because H bonding in H2O foils the T later than H2S. Yes, thank you. Okay, I hope that answers your question. Super duper. I like your name. Super duper. Super duper. Different types of bonds, strong bonds and weak bonds. We've covered these. Okay, and out of these, I think we're going to focus mainly on metallic bonding right now. Metallic bonding is very interesting, right? It's between electropositive element and another electropositive element. Matlab, metals. Yeah. What is so special about metals? I'm not talking about an ion. Okay, I'm talking about just like, say, a bar of iron. Fe, iron, not an ion. Right? So what happens here? Are they sharing electrons? Are they transferring electrons? Kuch aur kar rahe hain. So this is very complicated actually. It may seem like it's very obvious, but it's a little complicated. ठीक है? This is where solid state comes in. I know solid state delete कर दिया आपके syllabus से, but solid state की जरूरत है भाई, बहुत जरूरत है. So not assume, you know that they form this nice structure, solid state में, they form this lattice, and electrons are free to move around. That is the working theory. If the electrons are free to move around, then there is an attraction between this plus and these electrons, which are negatively charged. Okay. So yeah, that's what makes the world go around. Okay, this is electron C model. And if there are ज़्यादा electron है, तो ज़्यादा अच्छा है. As simple as that. और अगर size बड़ा है, तो it's not so good. So metallic bond strength. So for example, metallic bond in say Na will be more than that of Pb, right? Na is like an exception. And D block elements are crazy, guys. D block elements are absolutely crazy. Okay. So alkaline earth metals are greater than alkali metals. Why? Because 2 plus and 1 plus, right? They have 2 electrons and this have 1 s electrons, right? You have 2 and you have 1 electron here. इसीलिए, ठीक है? I'll give you these notes, कुछ लिखने की जरूरत नहीं है. D block elements, I said iron, they have exceptionally strong metallic bonding because of unpaired d electrons that take part in metallic bond formation. All of them, okay? You will see they are not really soft metals. And mercury is an exception because, boss, mercury to any d block. It has it has filled orbitals, etc., etc. Okay? So mechanical properties can be attributed to the strength of metallic bond. अगर melting point और hardness ज़्यादा है, it is usually because ज़्यादा electrons हैं, ज़्यादा metallic bond है. Good, this is what makes metals a good conductor of electricity, movement of electrons happens, etc., etc. ठीक है? Also good conductor of heat. Now heat का concept is very, very complicated, but I'll just leave it at that कि if something is a good conductor of electricity in metals की बात करना सिर्फ, okay, not you give me an example, diamond is a good conductor of heat but not electricity. ठीक है भाई, मैं सिर्फ metals की बात कर रहा हूँ अभी. If it has free electrons, it is going to be a good conductor of heat and electricity if it has free electrons. Okay, cool. Luster is an interesting property that also has to do with these electronic transitions. Okay, if you remember D and F block elements, हमने coordination chemistry शुरू की थी. We'll do it in revision. There are D transitions. Okay, there is a splitting that happens because of some sort of ligands and all of that, and उसकी वजह से there is a transition between different D suborbitals itself, right? And इसीलिए जो है D transition की वजह से they emit light, etc. That is one idea. ये बहुत ही कॉम्प्लिकेटेड चीजें हैं इफ यू गो इनटू डिटेल, बट हम लोग बस सुपरफिशियली कर रहे हैं कि पॉसिबल है कि आपको पूछा जाए टेस्ट में. लास्ट आइडिया अबाउट malleability and ductility, to have an idea about this. Okay, last question for the day. I think we're done with this pretty much. Yeah, we're done with the session. Last सवाल, बहुत सिंपल था सवाल. What is a metallic bond? बता, बहुत सिंपल सवाल. Is it ionic bond, polar covalent bond, non-polar covalent, or is it electrostatic in nature? What do you think? खत्म करें with this last question. दोस्तों बताइए, what do you think about this one? CFT. अच्छा, there is a bit of a lag between what I am saying and जो आपको सुनाई दे रहा लग रहा है. मैं CFT थोड़ा देर पहले बोला था, but it's okay, कोई टेंशन नहीं है. इसका क्या जवाब होगा बताइए? What is a metallic bond? आयोनिक है, पोलर कोवलेंट है, नॉन पोलर कोवलेंट है और इलेक्ट्रोस्टैटिक इन नेचर. हाँ, आयोनिक इज इंटरेस्टिंग. आयॉन्स तो है ही नहीं, आयॉन्स नहीं है, राइट? द प्लस चार्ज दैट यू सॉ इज बेसिकली द न्यूक्लियस इन द सी ऑफ इलेक्ट्रॉन्स वाला बिजनेस, राइट? एंड देयर इलेक्ट्रॉन्स, सो इट्स नॉट आयोनिक. पोलर कोवलेंट मेक्स नो सेंस. कोवलेंट क्यों होगा? नॉन पोलर कोवलेंट, भाई कोवलेंट नहीं है. ओनली ऑप्शन रिमेन्स इलेक्ट्रोस्टैटिक. व्हाई इलेक्ट्रोस्टैटिक? हाँ, द इलेक्ट्रॉन्स फ्लोटिंग अराउंड, there's a big plus charge that is electrostatic. Like बड़े electrons are moving around. How is it electrostatic? देख यार, electrostatic means कि because of positive and negative charges. ठीक है? Electrons यहाँ पे और अंदर there are nucleus में protons. ठीक है? इसलिए the answer is D, electrostatic in nature. ठीक है? And with that we're done with chemical bonding. Yeah, काफी भारी chapter, I know. We did 9 sessions. Usually people did 9 1-hour sessions, by the way, where we solved a lot of questions. I don't think you'll find anywhere on the internet where you'll do 9 sessions में पूरा chemical bonding, वो भी 9 घंटे में. People teach for 20 hours, 25 hours. But that doesn't mean हमने कुछ छोड़ा है. We've done things inside out. But the onus is on you to do NCERT questions. Be like Lavanya. पहले करो NCERT के सवाल, फिर modules करो, फिर ऐप पे आओ, आकाश भाई ऐप पे, कहीं पे भी you can get awesome questions and awesome solutions. ठीक है? Thursday को मिलते हैं. We will start revision from scratch. ठीक है? पूरा physical and organic कंप्लीट करेंगे. We'll start with a couple of chapters from 11th, couple of 12th, then we'll alternate 11th, 12th, 11th, 12th. Then करेंगे physical and organic. जो भी NCERT का order है उसी order में करेंगे. And if you have any suggestions कि आप चाहते हैं कि मैं NCERT का पूरा वो आपको दिखाऊं, you want me to go through NCERT, किसी ने बोला था in one of my videos कि sir NCERT को थोड़ा highlight करिए. We'll do whatever you want. But let me know in the comments what kind of sessions you want. when वो revision शुरू कर रहे हैं Thursday से. ठीक है? चलिए मिलते हैं. Thank you for being so awesome and checking out these sessions. Do share this with your friends if and like this and subscribe and all of that, and that'll help us make such awesome content for you until NEET and many years उसके बाद भी. ठीक है? All right, चलो. Good night, folks. Yes, class खत्म हो गया पूनम. Bye. Bye, everybody. Good evening. Thank you for joining in. Trending shots. If I start preparing, can I crack NEET? Can I crack JEE? Figure out कर लो. NEET करना है, JEE करना है. दोनों करना है, दोनों कर लो. कोई टेंशन नहीं है. All right. See you, Kusuma. Thank you. Bye. Good night, Radhika. Thank you so much. See you, everybody. Thursday मिलते हैं 6 बजे 7 बजे. We'll figure out a time. Okay. Bye.